Hey guys, what's up? Welcome back to the coding practical class. So we're in the coding practical class or session 2, I think. So we're going to be covering the stacks in this session. So let's get down to the stacks conceptual part first. So I'm just going to introduce you guys to stacks. So a stack is a data structure which contains an ordered set of data. Stacks provide three main methods, right? Push, which adds data to the top of the stack. Pop, which returns and removes data from the top of the stack. Returns and removes. It's going to give us the value and remove that value as well. And then peek, which only returns data from the top of the stack without removing it. It's just basically stacks mimic a physical stack of objects. Consider in this example, as you can see, consider a set of gym weights, all right? Each plate has a weight, the data. The first plate you add or push onto the floor is both the bottom and the top of the stack. So the first plate which you're pushing, which is 50, it is the first and the last because there's just one, right? It's the first and the last. There's nothing below it, there's nothing above it, all right? After that, each weight added becomes the new top of the stack. So I'm putting on 60. Now 60 is the top of the stack. Once I push 50, 55, 55 is going to be at the top of the stack, all right? At any point, the only weight you can remove or pop from the stack is the top one, all right? From a stack of objects, visualize this yourself. There's a stack of weights put on a put on the rod. Once you need to remove something from that stack of weights, you can only go one by one. You can't just pull them all out on choice. You have to pull out the top one and then pull out the second one and then the third one, then the fourth one and so on. You can't just reach down on the last one and pull it out because there's obviously the first, second, third, fourth, etc. over it. So you can only pop and peek at the ones at the top, all right? You can peek and remove the top and read the top weight without removing it from the stack. The last plate that you put down becomes the first and only one that you can access. This is a last in first out structure. All right, let me just write this down for you. Uh, I can use this. This is the notes for the last class. Just gonna go a little bit down. All right. All right. So it's a last in first out structure. Last in first out data structure, which is short for LIFO. So the last thing that goes in is on the top of the stack. So it's the first in the order. So it's the last in first out data structure. A less frequently used term is first in last out or philo. That's probably used in queues, but we're not covering queues in this course or this cluster of sessions or in creating this game. We're not going to be learning about queues. So basically stacks are just the last in first out data structure, short for leaf, LIFO, leaf, or whatever you want to say, right? So we get back to this. So I hope you've understood how stacks work. All right, so how are stacks implemented? Now stacks can be implemented using linked list as the underlying data structure because it's more efficient than a list or array. Now you guys probably don't know what a linked list is. If you do, that's good, but I'm just going to run you through it. Obviously I shouldn't be having to run you through it, but we're just gonna run through it. If you give me a second, I think, yeah. So I'll read this out for you, and if you want to pause it and read it yourself, you can too. So I'm just going to summarize everything for you. A linked list is basically, as we studied nodes in our last session, is a like what would you call a path of nodes. There are two type of linked lists. Either it could be like only A could be linked to B, B could be linked to C, C could be linked to D. And the second type of linked list could be that A could be linked to B and B could be linked to A as well. It could be a two-way thing, all right? You can go forward and you can go backward as well, all right? But yeah. So the head node in the linked list is the first node basically. It's a group of nodes. The first node is the head one and the last node is in tail one. This should be pretty easy to understand. And then implementing a linked list is pretty easy. It's basically yeah, as I mentioned, it's just a head node, there's a tail node. You can transverse through the node and print out it in a list. All right, and obviously you can add a new head node. It's just you can pause the video and read all this, and then you can pause and see how we can implement it in Python if you're interested. But we're not going to be needing any Python implementation for linked lists in this course. So yeah, this is all about linked lists. So linked list is basically, as I mentioned before, a group of nodes. All right, a group of nodes. It could be either two-way, one-way. There's a head node, there's a tail node. You can transverse through the nodes and print it out in a list. And yeah, that's all. It's pretty much. And you can add a new head node, and you could remove a node by the same method that I mentioned in the previous video, where you were gonna link what, like if there's A, node B, node C. If you want to remove node B, you're just gonna link node A to node C, and B is gonna be out of your path. So that's how you remove a node, and you can check it out in the Python implementation as well. But pretty much linked list is just a term I'm using to explain stacks, but it pretty much has nothing to do in our project. If you can see right here, there's absolutely no implementation of linked lists whatever. Obviously stacks are being implemented having linked lists as the underlying data structure. But once I obviously clear you out on the stack Python implementation, you're going to be clear on the linked list Python implementation anyways. So I'm just getting it out so anybody who's confused while I'm explaining this would know what linked lists are. So depending on the implementation, the top of the stack is equal to the head node, as I mentioned, right? And the bottom of the stack is equal to the tail node. Remember, this is the linked list. This is being shown in a stack. Alright, a constraint that may be placed on a stack is its size. Alright, this is done to limit and quantify the resources the data structure will take up when it's full. Attempting to push data on an already full, for example, if the limit of the stack is 3 and it's full right now because it has 3 nodes inside it or 3 pieces of data inside it, and if I try to push something onto it, I will have a stack overflow, right? And imagine if the stack was empty, and if I try to pop something out of that stack, remove something out of that stack, it would be empty, and that would result in a stack underflow. All right. So basically, summarizing this all, we're just gonna review this. All right. Stacks contain data nodes, support 3 main operations: push, pop, peek. You remember push, it just adds data to the top of the stack, basically becomes a new head node if you look at it in in a linked list point of view, and pop removes and provides data from the top of the stack. Peek removes data on top of the stack. Implementations include a linked list or an array. We're probably going to be using a linked list implementation, and they have a limited size, so you have to, when you're creating a stack, you have to give the size, you have to give the limit, you know? You have to give what the limit of the stack is to prevent yourself from stack overflow and underflows. So stacks process data last in first out. We already discussed that. So let's just get down to the Python implementation for this, and we should be done with stacks pretty quick. I think I saved it here. I definitely did. Oh, I didn't. I absolutely did not. Yep. So yeah. So we have stacks right here. I'm gonna walk you through this Python implementation. All right. We have the basic. We're using classes. So we have the basic constructor method. And now this is, pay attention over here. This is important. In the constructor, we keep the size. We keep the top item, which would be the head node if you would look at it in linked list perspective. And then we have the limit. As I mentioned, you need to define the limit to prevent yourself from stack overflow and underflows. And then it's the name, because when you're dealing with multiple stacks, as we will be in the Towers of Hanoi project, because if many of you don't know, I'm going to just show you Towers of Hanoi. Basically, it's three stacks. Basically, hold up. I can show you. Yeah, so basically three stacks, and you can push things onto it. It's three things. So we need to have like name. We have to have the name construct in the constructor there, because this is gonna be left, middle, right, or 1, 2, 3, or whatever. But we need to have multiple stacks. So we need to separate them from each other, and that's gonna be using the name. All right. So before I tell you how I've implemented push pop peek with Python, I'm just going to show you these helper methods just to get them out of the way first. So all of these are called the helper methods. So first of all, we have the has space helper method, which is just going to check if self.limit is greater than self.size. So basically the size is, for example, this is the left stack. Its size right now is 3. All right. Does it have space? Dot limit is greater than size. 1,000 is greater than 3. Yes, it has space. It's gonna return true. All right. Then we have def is empty function basically. Why am I saying def? I'm crazy. All right. So it's just gonna return a true or false statement for if the size of the stack is 0. So if we ran that function method on this stack, is going to return true, and if we ran that on this stack, it will return false. And after that, we have the get name method, which is going to simply return you the name of the stack. And then we have the print items helper method. It's just going to print all the items on the stack. So for example, what can I say? So it's just going to tell me how many of these blocks is on a stack. It's going to print them all out, right? So now we can get down to the important stuff. So to make the push method, we have to first of all check if the stack has space, because if we don't, it's going to result in a stack overflow, which we don't want, right? So if it has space, we're going to move on. We're going to define it as a node with a value, all right? And then we're going to set the next node as the top item, because obviously the stack is empty. So if I add a block onto this, what would be the next item? The next item would be the top one. Remember, last first out, right? And the top item would equal to the item as well, all right? And the self dot size would increase. It would have an increment of 1. All right, and if it didn't have any space on it, it would just print no more room, and it would tell me that I cannot put anything onto the stack. All right. Right. So I'm just gonna recap this. All right, I'm just gonna recap this. It's just, once it has space, it's gonna create an item, right? That item is gonna be a node. It's gonna be a node, as we studied previously. So that node, its link to the next node is going to be the top item on the stack. So if I put on a block onto this, what is going to be the next item? It's going to be this red one. All right. If I'm putting on a purple, for example, on this, the next item is going to be the red one. If I put another one, a yellow one on it, the next item is going to be the purple one. All right. So the next node is the top item of that stack. And then the self.top item now would change to the item that I just put on. So if I put on the purple one, the next one is red, and the top one now is the purple. And the size has increased by 1 because before it was 3, now it's 4. So that's all that push does. Then we have pop. As we remember, in pop, it was going to return us the date. It's going to return us the data and remove that data from the stack. All right. If self.size is greater than 0, because we could have just put what is it? We could have just put is empty over here, but we're just gonna put if self.size is greater than 0, is greater than 0. If self.size is greater than 0, we're just gonna return the. Now we're on peak. Yeah, we're on pop. So if self.size is greater than 0, we're gonna make the item to remove the top one, because remember, when using pop and peak, we can only remove and return the top item. All right. So the item to remove would be the self.top item. So the self.top item would equal to the item to remove dot get next node. I think you guys couldn't catch me up there. I think it would be better if we opened it in the Towers of Hanoi project itself. So I keep on going over the node section to explain all the methods that are being used here. So yeah, hold up. It's really hot in my room for some reason right now. So we were here, right? So the top item, the item to remove is a self.top item. All right, remember, top item. Remember, it's a top item, and the self.top item. Uh, and now, like, once we're gonna remove the top item, what's gonna be the new top item? The new top, if I'm gonna remove this red one, what's gonna be the new top item? It's gonna be the green one. So how do I implement that with Python? I have to be smart about this one. It's gonna be the item to remove dot get next node, because we're gonna utilize this getter method from our node class. I'm just gonna put it there because item is a node, remember? Item is a node, so we can use the getter method for the node, and where so we can use the getter method of the nodes. So the self.top item would become the item under the top item right now, and the top item would be removed, and we would increment a -1 into our size, and obviously we need to return the value of the item we're removing as well. So we're just gonna put on basic. We're just gonna put on the getter value, the getter method of get value from the node class. After that, let's move on to peak, the peak method. Peak, we're just looking at the top item, and we have to uh, first of all check so we don't have a stack underflow. It's greater than 0. Yes, it is. We just return the top self.top item dot get value. All right. Whatever the top item is, we're gonna get its value and return it. We've peaked. All right. And if the self.size is less than 0, or if it's not greater than 0, then we'll just say nothing to see here. It's a little cheeky, but you could just put on stacks. You can put on whatever you want. Just being a little cheeky there. So we've covered these. We've covered that. After that, we didn't. You might have observed that we didn't use this helper method in any of these three in any of these three, whatever you want to call them, in any of these three methods. So why is this here? This is going to be used later into the game. I'm just going to show you where it's used. Hold up, I'm just going to show you where it's used. So, you know. It's going to be used in the last part, but yeah, it's going to be used right here. It's not used in that part, but we need to put it in that part because it completes our stack class. But probably when you would be creating your project, you would be done until here, and then once you do this, and when you're doing the last part, which is the when you're doing the last part, which is oh no, when you're doing when you're doing the last part, yeah, when you're doing the last part, you will notice that you need to print the items. So you're gonna go quickly back up onto your stacks part, and you're gonna create that method into the stacks class. So what this basically does is the pointer. Obviously, I remember if you remember, I mentioned what pointers, like the links to the other nodes, are also referred to as pointers. All right, so the pointer is equal to self.top item. All right, print list. We're gonna create an empty list because whenever I think you've covered this already, so I don't need to talk about this. Then we're gonna increment a while loop. All right, while pointer means while there's a top item, because obviously then again we don't want this stack underflow. Print list dot append pointer dot get value. So it's just gonna keep on. It's gonna it's gonna print the top value, and then the pointer is gonna become the next node, and then it's gonna print its value, and it's gonna become the next node, and it's just gonna. And once we're done with this while loop, we'll probably have a list of like we'll have a list red, green, blue. All right. All right. Where was I? Yeah. Once we have that list, we're gonna reverse it because it's gonna give our input like it's gonna give our input in red, green, blue, whereas we actually need it to be blue, green, red. All right. And then print. I think you've all obviously learned the formatting, string formatting method. If you haven't, it's just this zero, uh, where the if you see there's a zero in this parentheses, it indicates that this is gonna go in here, and if this is one, this is gonna go in here. All right. So if I switched those up, this would go in here, and this would go in here. But if you left it as is, it's gonna be in order. So it's gonna go here. This is gonna go here. But I just like to keep them like this. So is this gonna get the name, and then it's gonna print the list. So for example, we would be on the left stack, it would say the left stack, and it would print everything on the left stack, green, red, blue, from bottom to top. All right, that's all for our stacks class. Next class we will be getting up to the I think we'll probably be covering the game and setting up the game part, because we can just because the game part is pretty short, and many of you who are just seeing this right here even are thinking that this is really easy. So we're just gonna cover these, create the stacks and set up the game parts, and we'll do the last two parts in the continuing two classes. That's all.